Hello everyone, my name is Oorja and welcome to DhiNexus. In today's session, we'll be covering chemical properties of alkyl halides, that is elimination reaction and reaction with metals. At DhiNexus, we try to make learning simple, clear and engaging. So stay tuned till the end of the session. So what all topics will be covered? We'll be covering elimination reaction, in which we'll be learning about formation of alkenes. The reaction with metals will be looking at formation of Grignard reagent, which is highly important and useful in solving conversion questions. Along with that, we'll also have a look at Coles reaction. And then there will be some NCERT questions as well as P-values of IIT JEE Mains. So students who are preparing for CBSE board exams or competitive exams are advised to have a look at this video. Moving on. So the first is elimination reaction. What happens in this case is you take any Rx. Let me write down a general equation. This is my alkyl halide. I reacted with alcoholic KOH. In place of KOH, I can also take NaOH. I heat it at some temperature, and what I get is an alkene. So in this case, the difference, the similar reaction is that of alkyl halide with aqueous KOH. So in that case, what I achieve is an alcohol. Students tend to get confused because there's both KOH in both the cases, but do remember that the opposite of the condition is like if I want to make alcohol, I will be taking aqueous condition. If I want to make alkene, then I will be taking alcohol. So what is happening? This is also called as beta elimination reaction. Why? Because this is my butyl N-butyl bromide. In this case, the alpha will be that carbon to which the bromide or any halide ion is attached. The next adjacent carbon to it is called a beta carbon. So, in presence of alcoholic KOH, the hydrogen from this beta carbon is eliminated, and so is the bromide from the alpha carbon. And what we achieve is a butane. However, there is one conundrum that we face if we have something like this. When the halide ion is not attached to the terminal carbon, then there is a possibility of achieving two kinds of alkenes. And which one would be the major product and which one would be the minor? So to help us understand which one should be the major product, we have something called as a Sedgwick. In this case, the hydrogen atom is removed from the beta carbon. So you have beta at both of these places with the fewest number of hydrogen atoms. So as we can see that the beta carbon with the lowest hydrogen will obviously be the one here. The terminal one will always have higher hydrogen. So this is going to be my minor product, and this will be the major product. You can also say that the alkene formed is the one which has more number of alkyl groups substituted. So if I just make a box here like this and look at the alkyl groups directly attached to the double bond. Here I have only one directly attached. But in this case, I have two alkyl groups. So this is highly substituted or more substituted alkene, and hence it is called the major product, and this will be the minor product. There is another rule which is opposite to Sedgwick rule, that is called Hoffman's. In case of Hoffman's rule, what we see is that major is the one which is forming the least substituted alkene. least alkyl substituted alkene. So according to SIDS, according to Hoffman, this shall be my major. And this will be my minor. Sometimes a question or two may be asked about this in the IIT JEE Mains exam. Moving on, we'll be looking at the next type, which is reaction with metals. So alkyl halide can react with two types of metals. First, we see, let me write the general equation. We have Rx plus Mg giving me Rmg. This is called Grignard reagent. If I am taking CH3Cl plus Mg, it will give me CH3MgCl. Now, this is very much useful in preparing a number of other hydrocarbons. It can be used to prepare hydrocarbons and can be used for preparation of aldehydes and even preparation of alcohols. So, one thing to note about Grignard reagents, however, is that if I am reacting them in even a trace of proton, then what I get is a hydrocarbon. So even a trace of proton can lead to reduction and I will get a hydrocarbon. Hence, we must prepare this in dry conditions. This formation of Grignard reagent must be done in the presence of anhydrous conditions so as to avoid formation of hydrocarbons. But again, on the other hand, this can be used to prepare hydrocarbons if I react it with water. Secondly is Wood's reaction. In this case, if I have two molecules of alkyl halides, and I react them with dry ether and acetone, what I achieve is an alkane which is symmetrical. So this alkane is going to be symmetrical and it will form even number of, like it increases the number of carbon atoms which has even number of carbon atoms in a. This method is not used to prepare odd number of alkanes, as then we achieve a mixture of products. And we already know that if we get a mixture of products anywhere, such a reaction is not feasible because then you are, utilizing a lot of resources in trying to separate the major product or the desired. So such a case is not observed when I want to prepare, for example, propane. And if I want to prepare ethane, so what can I take? CH3Cl plus 2N along with CH3Cl. I'll get butane. Sorry, I'll get ethane, which is C2H6. Please note that this reaction does not work well with third degree tertiary alkyl halides. Because tertiary alkyl halides undergo elimination instead of forming alkenes. Moving on, we'll have a look at some NCRT questions. So this one, why should Grignard reagents be prepared under anhydrous conditions? Like we already saw, that Grignard reagents are highly reactive. How shall you write this particular question? Grignard reagents are highly reactive compounds, highly reactive, and even a trace of proton can lead to formation of alkanes. Hence, what do? We prepare them in inert atmosphere. Which means even having oxygen or CO2 can be fatal for the particular desired product. Moving on, I have some conversion questions which are very interesting and usually fun to solve. So I have a propene. This is my propene. And what do I want to prepare? I want to prepare a propanol. I would suggest that you pause the video and try to attempt these questions yourself so that you know where you stand and whether or not you're able to solve the questions. If you're not able to solve the questions, then I would suggest you to note down all the reactions at one place, especially when you're solving conversion questions or the questions where you have to write the product. So let's have a look. You have protein, you have alkene you want to prepare, and alcohol. Now, what do I know about this? Can I prepare, if I reacted with HCl, can I get an alkyl halide? Yes. And this alkyl halide, in fact, the best reaction should be if I take HBr, if I take HBr with peroxide. Why? Because this reaction is anti-Markov. So I will get a bromine on this, in this case here, and that when reacted with, what conditions do we use to prepare alcohols? We put aqueous KOH. The opposite, just like we discussed a while ago. So CH3, CH2, CH2, and OH. This is the direct way to produce. There can be other ways of preparing this particular reaction too, but always remember that conversion should, have minimum steps. If you are putting a lot of steps, then such a conversion is not feasible. Because in the lab, or even if we're in a particular, we're working for some industry, we want to use less resources and the least amount of time. Moving on, we have ethanol and we want to prepare propane line. So CH3, CH2, OH. And what is propane nitrate? Always write the reactants on the left-hand side and products so that you have a vision of what to prepare, and then you can try to put all the pieces of the puzzles together. So propane nitrile, if you remember, alkyl nitrile is RCN. This is something we discussed in the nucleophilic substitution reaction video. If you've not watched it, I suggest that you watch it. Otherwise, this may not make a lot of sense. So this is the propane nitrile. What do I react it with? First, I will convert it to alkyl halide. So SOCl2 is what I'll take. The reason for taking SOCl2 is the fact that the byproducts in SOCl2 are gases. I get SO2 and HCl. So the major product that I want to receive does not have to be pure. And then I can just react it with KC. So this was nothing but a two-step reaction, as you can see. This is done. Next is ethyl chloride to propanoic acid. Also quite easy. So I have CH3, CH2, Cl. First, I will react it with KC. Whenever I want to increase the number of carbon atoms in a particular chain, I will use KC because this gets added up and the carbon are also gone. So CH3, CH2, Cl. What is this? This is nothing but propane nitride, like we saw before. And we will do complete hydrolysis. So complete hydrolysis is done. H3O plus, OH minus. In complete hydrolysis, propane nitride will be giving us propanoic acid. So not very difficult if you remember the reactions, but it can feel a little tricky if these reactions are not on. So next part, we have what happens when ethyl chloride is treated with aqueous pH. Quite easy. So CH3, CH2Cl, and I am treating this one with aqueous KOH. So alcoholic KOH gives me alkene, but aqueous KOH will give me alcohol. CH3, CH2. Quite easy. Next is, which one will react faster in SN2 with OH minus? CH3Br or CH3? So methyl iodide or methyl bromide? Which one should be the fastest in case of SN? Always remember so in this case, the point of confusion can be that, okay, both of them are 1 degree only. So which one should we go ahead? Always remember that whether SN2 or SN, the leaving group is best. Iodide is the best leaving group. Then we have bromide. Then we have fluoride and then fluoride. What is the cause or what is the reason for it? Iodide ion has a low bond enthalpy, but in the other case, or on the last series of, in case of halogens, the last atom, which is fluoride, has high bond enthalpy. CH3 has high bond enthalpy. So it becomes difficult to break this. But on the other hand, the bond also becomes quite large and it is easier to break. So which one will be the faster? CH3I or methyl iodide? Let's have a look at some of the questions which were also seen in IIT JEE Mains. And these are quite easy. So alkyl halide is converted into alkyl isocyanates. What is alkyl halide? RX. What is it converted into? RNC. My RCN is alkyl cyanide, but isocyanide is when I just shift the atoms. So again, if from our knowledge of nucleophilic substitution reaction, we will put AgCN. So this is wrong, this is wrong. Also remember that in case of preparing alkyl cyanide, I can take KCN or NaCN. Both will give me alkyl. So this is also wrong. The correct answer is AgCN. The product C in the below mentioned reaction is this. Of this one reaction will be first we'll get an A, then HBr, then this. So this may seem a little long, but it's very easy. So if I'm reacting propyl bromide with aqueous alcoholic KOH. So alcoholic KOH is going to give me alkene. I will be getting a propene. This is elimination reaction. This is my product A. Now it's reacted with HBr. In reaction with HBr, there is no peroxide, so it is going to follow Markovitch problem. CH2, CH3, and I will get addition of a bromine. And finally, I'm reacting it with aqueous KOH. So with aqueous KOH, what will I get? I will form a alcohol. But where should this alcohol come? Alcohol will be at this position where my bromide is. Directly, the substitution is happening on the second round. So correct answer would be B, propane 2. And you can see how easy. And it came in IIT JEE Mains 20. Couple of more questions. The major product in the reaction of this. So I have a tertiary alkyl halide. I have a tertiary alkyl halide. And what is this? This is alkoxide, sodium or rather potassium alkoxide. If you remember, Rx plus RO Na, it can be Na plus or K. What will I get? I get an ethyl. Here it is a tertiary alkyl halide. So although somebody naturally we would think that this should form product like this. That is not the right answer. The right answer would be this one. 2,2 dimethyl propone. That is, elimination takes place whenever you have tertiary alkyl halide. It does not go and lead to the formation of ethers. Ethers are not formed in case of tertiary alkyl. More about this will be discussed when the series of ether or formation of ethers and their chemical properties are covered. But please remember, Williamson synthesis does not yield to ether formation with tertiary alkyl. The last but not the least, major product formed in the following reaction. So let's see what we have here. This is 1, 2, 3, 4. And then on this one, I have 2 compounds. So then CH, then CH3, and I have one more CH3. Do remember to always expand the structure. So this is what I have. This on reaction with HBr. At first, I will get a carbocation formation. So from here, the carbocation is going to form at this point. Now, this carbocation, should we just add the bromine here? The bromine will first be a shifting of the carbocation. If suppose I have a hydrogen here, then this hydrogen goes here and my carbon comes here. So rather, not carbon will rather show the shifting of the carbon. So this is what I get. Now my carbocation is here. Why did I shift it? Because here the carbocation was 2D. The carbocation was 2D. And in this case, the carbocation is P. This type of shifting is called as 1,2 H shift. 1,2 hydride shift. This is done whenever there's a formation of a carbocation, because carbocation intermediate always tries to be more stable. More number of alkyl halides, more stable will it be, and then my bromide ion will attach it. So if you just see from the various options, the correct answer is this D. Okay, and this was asked in JEE Mains 2020. So you can see that not all the questions of IIT JEE Mains are, outside of it. If you properly read NCRT, if you solve the NCRT questions as well and objective type so that you know how to eliminate the options as well, IIT JEE Mains is very much new. So if you liked the video, if you found it helpful, please like it and share it with your friends. And stay tuned by subscribing it to the channel so that you don't miss out on the future.